There's something new from the Voyager probes. NASA has announced that these space veterans flew through a mysterious wall of fire during their journey into interstellar space, encountering temperatures of up to 50,000 degrees Celsius. Today, we'll explore what this red-hot cosmic zone is all about and why the probes didn't immediately burn up. But that's not all. Voyager 1 also recorded a powerful gamma-ray burst that left even the most experienced astronomers baffled. Not only was its intensity unprecedented, but the burst and its afterglow didn't match any existing models, leaving researchers struggling to explain what they had witnessed. So, stay tuned if you want to know exactly what Voyager 1 discovered out there. Have you ever heard of the Voyager probes? Launched into space in 1977, Voyager 1 has now traveled an astounding 25 billion kilometers from the Sun. The only other man-made object to have ventured as far is its twin, Voyager 2, now just under 21 billion kilometers away from us. What makes their journey even more remarkable is that these two identical probes weren't originally designed to travel into the mysterious realm of interstellar space. Their initial mission was to shed light on our cosmic neighborhood and study the outer planets, which were still largely unexplored at the time. But after completing that task, NASA allowed the probes to continue their journey, transforming them into the first spacecraft in history to leave the solar system. And if you think this achievement was powered by cutting-edge technology, think again. By today's standards, Voyager 1 and 2 are hopelessly outdated, especially when compared to the devices we carry in our pockets every day. No wonder, since the Voyager probes are, after all, children of their time, built with the state-of-the-art technology of the 1970s. In plain terms, that means our modern cell phones now exceed the storage capacity of the Voyager probes by a factor of 1 million. The scientific mission data is still stored on magnetic tape with a capacity of just 536 megabits, and even the data transmission rates of today's mobile phones are nearly 40,000 times faster than those of these NASA veterans. Despite their outdated technology, Voyager 1 successfully set course for the edge of the heliosphere and reached the Sun's protective magnetic bubble in 2012. Its sister, Voyager 2, followed 6 years later. Since then, the two probes have been delivering unique insights from a region of space that has never been explored before. Recently, however, and this is a truly exciting part, NASA revealed that during their journey into interstellar space, the Voyager duo encountered a phenomenon now known as a wall of fire. And that name is no exaggeration. While the surface of the Sun reaches temperatures of about 5,500 degrees Celsius, the Voyager probes reported scorching temperatures of up to 50,000 degrees Celsius when passing through this mysterious zone. This naturally raises a fascinating question. How is such heat possible so many billions of kilometers away from the Sun? Shouldn't space out there be freezing cold? To answer this, we need to briefly examine the structure of our cosmic neighborhood. The Sun continuously ejects charged particles into space in the form of solar wind, creating the heliosphere, a vast, protective bubble that extends far beyond the planets and shields us from harmful cosmic radiation. The outermost boundary of this bubble is known as the heliopause, and by definition, interstellar space begins where the solar wind becomes so weak that it can no longer push back against the pressure of the interstellar medium. It is here, at this cosmic frontier, that the wall of fire merges. This is a diffused gas, dust, and plasma that fills the space between the stars. However, the edge of our solar system isn't marked by a sharp, rigid boundary, but rather a dynamic transition zone where two powerful cosmic forces, the solar wind and the interstellar medium, collide and interact. It's precisely in this chaotic frontier that the Voyager probes encounter the now famous wall of fire currently making headlines. But what does that actually mean? Did the probes really pass through a region of space that is literally on fire? Not exactly. Although temperatures in the area range between 30,000 and 50,000 degrees Celsius, there was no visible combustion, because combustion requires oxygen, and there's none in this part of space. In reality, the wall of fire is a cloud of high-energy particles. Its intense heat is generated by the rapid solar wind, traveling at speeds up to 800 kilometers per second, slamming into the slower-moving interstellar medium. This collision produces magnetic turbulence and compression, forcing particles into a much higher energy state. But then comes the big question: how did Voyager 1 and 2 manage to survive flying through such an inferno without being instantly incinerated? The answer lies in the extreme low density of the region. The plasma, though incredibly hot, is so thinly spread that it couldn't physically damage the probes. Yet temperature alone isn't the only reason this world fascinates scientists. What's even more intriguing is its unexpected magnetic orientation. Before the mission, researchers believed that the magnetic field beyond the heliopause, the boundary of the heliosphere, would be vastly different from the one inside it. But the Voyager data challenged that assumption, revealing an alignment that continues to puzzle astrophysicists and hinting at a deeper, more complex structure in the space beyond our solar bubble. However, the Voyager data now show that the magnetic fields inside and beyond the heliosphere run almost parallel to each other, a surprising and significant discovery. This unexpected alignment suggests that our solar system is far more closely connected to its surrounding interstellar environment than previously thought. It challenges older models and opens up new questions about the nature of space just beyond our solar bubble. But the revelation of the so-called Wall of Fire wasn't the only astonishing spectacle the Voyager probes uncovered in the depths of space. On October 1st, 2022, Voyager1 recorded something truly extraordinary. Its instrument detected a sudden and inexplicably large influx of high-energy radiation. What initially seemed like a mysterious spike soon revealed itself as a harbinger of a cosmic event so intense that it would reach Earth 19 hours later, an event that turned out to be one of the most extreme ever recorded. The culprit was gamma radiation, and it was so powerful that nearly all major observatories, including NASA's Swift and Fermi telescopes, were overwhelmed. It soon became clear this was a result of an unprecedented gamma-ray burst, one so extraordinary it earned an entire special issue of the Astrophysical Journal letters. Officially, the event was named GRB 221009A. Unofficially, it gained the nickname BOAT, short for brightest of all time, and rightly so. The burst carried an energy of 18 teraelectron volts, making it a staggering 70 times brighter than any gamma-ray eruption ever observed. But that wasn't all. The gamma-ray burst event was also accompanied by an extremely unusual jet of radiation that defied existing models of how such afterglow should behave. Specifically, scientists identified a new and unexplained component within the radio spectrum of the jet, one that presented a whole new mystery. Other parts of the electromagnetic spectrum also revealed oddities. Most notably, the jet itself appeared to be unusually focused and narrowly directed. In April of the following year, researchers finally traced the origin of the eruption, only to uncover yet another baffling twist. One might assume that such a violent cosmic explosion would stem from a similarly violent cause, but surprisingly, that wasn't the case. High-resolution data gathered by the James Webb Space Telescope spectrometer revealed that BOAT, the brightest of all time, was triggered not by some exotic event, but by what appeared to be a surprisingly normal supernova. This revelation led to a new, confounding question. How could the death of an ordinary star trigger an event so rare it's estimated to occur only once every 10,000 years on Earth? While there's still no definitive answer, experts believe it's possible that this powerful gamma-ray burst was linked to a specific kind of supernova, one involving a fast-spinning, massive star. When such stars collapse, they can emit tightly focused jets of particles traveling near the speed of light. If these jets are particularly narrow and intense, they can create a blindingly bright, high-energy beam, just like the one recorded during the BOAT event. In fact, it turned out to be one of the narrowest gamma-ray burst jets ever observed, which may explain how so much energy was concentrated into a single, record-breaking phenomenon. Still, these remain educated theories. Scientists openly acknowledge that other unknown factors could be at play, and until the full story is understood, solving the mystery will require years of ongoing research. Luckily, not everything requires such patience, like clicking a subscribe button or giving a thumbs up. Do that, and you'll be the first to know when the next cosmic discovery unfolds. See you soon.